All right, now we come to cosecant and secant. What are some properties? Well, I know you can look at this, but I'm going to just show you. Remember how sine and cosine look like waves? They would be waves that would fill in kind of like this. The secant and cosecant, notice, are like parabolas. So the asymptotes occur every time the normal curve goes through 0. So this one here is cosecant, it's CSC, and that's because the sine curve, if you remember, starts at the origin, it goes up, and those would actually touch each other. I didn't draw it correctly. It would actually come up and touch each other, and then it would go down, and where it hits 0, that's where that asymptote comes from, because CSC is just the same thing as 1 over sine x. They're reciprocals. So that's where it hit 0, and then it would go down, they would hit at that point, come back up, and so on. That's how sine x would look. This would be the same, but it would be with cosine. Cosine starts up here, it goes through, it would hit down here, come up. This would be cosine curve because secant is the same thing as 1 over cosine. They're reciprocals of one another. So that's how these work. You might notice that this has origin symmetry. They're flipping diagonally. This is split even. It's down the center, so that's even symmetry. So now, let's talk about finding, and I didn't point out the period on these is now 2 pi again, just like they were last lesson. So now it says locate the vertical asymptotes. Well, let's start. If this is secant, negative secant x is the same thing as negative 1 over cosine of 2x, which means to find the asymptote, I need to find out when does cosine 2x equals 0. So that's what I'm trying to find. When does cosine 2x equals 0? The first thing I do is I do the inverse. So cosine inverse of 0 equals 2x. And again, the calculator will give me parentheses there. Don't be alarmed. To get x by itself, we would divide by 2. So I would divide everything here by 2. So I'll go to my calculator. And we were close to it that time, but that was sine. So let's do cosine inverse of 0 divided by 2. And I get this. Now I'm going to divide this by pi to get the answers in terms of pi. And that's 0.25, or 1/4. All right, so we get here that this is, if I wanted to get the decimal, I would say 0.78539. So I'll just say 54 equals x. This is rounded, so I'll do approximately x, which is the same thing as 1/4, pi equals x. That's the exact. So I want to use that. That's where the first vertical asymptote should be, at 1/4 pi. This is half a pi, this is 1/4 pi, so we're accurate. So how do I find the other ones? I look at the period. My period, I use the b value. So here my b is 2. It's the number in front of x after the trig function. So my period equals 2 pi divided by b, which is 2 pi divided by 2. 2's cancel. You're left with pi. So that means the vertical asymptotes would occur starting at 1/4 pi plus pi z. So any integer added to it, whether it be positive or negative numbers, that's how you would find this. That's our vertical asymptotes. Now we've passed on. Let me see if there's anything else we need to find. Nope. And so that would be our graph. We start at 1/4 pi, then we'd have the next one. And I pause there for a moment because it threw me off. Here we have one at 1/4 pi, and the next one comes at 3/4 pi, not 1 and 1/4. So this one is the next period. Here's what I've been forgetting here. The period is technically always absolute value, and I've just taken it as the positive. But if you remember, when you solve absolute value, you do it once as it being positive and once as this number being negative. So if it were 2 divided by -2, we would have a period not only of, well, when you do period here, of pi, but you would also be having a negative pi. Let me try to say it this way. And since this is even, it's reflecting here on the y-axis. If you have an asymptote at pi over 4, you'd also have to have one at negative pi over 4. And so you would have a double going on here is not only that, you would also have a negative 1/4 pi, and of course the same period, that doesn't change. But you would need to add this in here to our answers as well. So these are where the vertical asymptotes, there would be two vertical asymptotes occurring. So one of them is here, and it recurs every pi. So it would go from this one right there, and it would jump and become this one. And it would jump over here and be this one. But this is the second asymptote, and it goes from there to there. So these two would bounce together like that to that one. So that's why there's double the asymptotes there, is because this is the even function, and so you would reflect them across. Let me try another one. This one will be a little easier, I believe, because it is a sine inverse sine. So this is the same thing. It's saying when does sine x, not of x, I'm sorry, sine of x plus pi over 3 equals 0. That's when we'd have a vertical asymptote, because CSC is the same thing as 1 over sine, and you're not allowed to divide by 0. So when does that equal 0? Well, we first take an inverse. So sine inverse of 0 is equal to x plus pi over 3. To get x by itself, we subtract the pi over 3 from both sides. And so this needs to stay outside the inverse, so we get sine inverse of 0 minus pi over 3 will equal our asymptote. Let's go to our calculators. So we take the sine inverse of 0, and we're going to subtract pi over 3. And I get this. Now let's get this in terms of pi. So I'll divide this by pi. And it's negative 1/3. So we have one here, and negative 1/3 pi. Negative 1/3 pi equals our asymptote. So if I go over here, I should have one at negative 1/3 pi. Now let's check the period. Remember, period is the same thing as 2 pi divided by our b. In this case, b equals 1. So the period is 2 pi. So with that being said, we should have vertical asymptotes when at negative 1/3 pi plus 2 pi z. And it looks like, again, that we have them occurring a little bit more often than that. So this one would jump all the way over to almost here. So if this is almost 0, this will be almost 2 pi. So that's jumping there. And so we do have this one. It's easier to see in the picture that there's a second value, because everywhere there's a break, there's this vertical asymptote. And so you see there has to be one right here in between those two. And to be honest, I'm just frankly struggling with how I'm supposed to teach you to get the second one at this stage without knowing more of the. I can try to go from the hand trick, but what you need to know is there's two ways of getting sine of 0. The calculator only gives you one. It gives you the one that occurs closest to the positive x-axis. So sine is like your y values. If you think about your hand trick, if you're looking at your left hand, which finger would, for y values, has a 0? Well, it's your pinky, which means that's a value of 0. So here's how they got the answer is they did 0 minus pi over 3, which is negative pi over 1/3 pi. That's how we got that. Well, there's another place the y is 0, and it's in the between the second and third quadrants that the y is also 0. So you get your other answer at pi. But again, I don't know how to teach you this at this stage. You need some more lessons under your belt to grasp this. But this is how you would find the other one, is you would say that this value could also equal pi, and you would subtract, and you would get 2/3 pi as the other value. Okay, so you would have 2/3 pi as the other asymptote, and this occurs every 2 pi as well. And I'll put that in. So that's how you get those. And again, I'm sorry, I'm just struggling with how, at this stage of your knowledge, how to get you to find that other asymptote. Here's one now for you to try.